In this video, we will discuss the there exists a unique quantifier. Okay, so we've seen the there exists quantifier in the last video, so now we're going to introduce a slightly different version of this. So when I talk about the proposition there exists a unique x in the domain such that p of x is true, the word unique means I want there to just be one. And the way I represent the word unique is by an exclamation point. So the exclamation point is going to be my symbol for unique. And the way I denote there's a unique x such that p of x is true, I use my sort of backwards e symbol for there exists. Then I put that exclamation point, that means unique. There exists a unique x. And then I write p of x. So this is there exists a unique x such that p of x is true. All right, so let's do an example where we use this. I'm going to let the domain of x be the reals. Let's let t of x be x to the third minus 4 equals 0. S of x is x squared equals 4x. And I want to evaluate the truth value of these propositions. So in part A, it says there exists a unique x such that t of x is true. So is there a unique x that makes this equation true? Well, I can just solve the equation and figure out if that happens. So with this equation, I get x to the third equals 4. And then I cube root both sides, and I'll get x equals cube root of 4. And I don't need to put a plus or minus because I'm not doing an even root on both sides. I'm doing an odd root where I don't need a plus or minus. And this is the only answer. In other words, that's a unique answer. So part A is true since x equals our cube root of 4 is the only solution. It's the only value of x that's going to satisfy that equation. Okay. All right, let's look at part B, which says there exists a unique x such that s of x is true, such that this equation is true. So for this equation, I'm going to solve it in two ways. I'm first going to do it incorrectly because there's a really common mistake people make with equations like this, and I want to clearly point out what that is, and then I'll talk about the correct way of doing it. So the incorrect way first. If I have x squared equals 4x, let's divide both sides by x. So x squared over x equals 4x over x. And then I get x equals 4. Well, if I look back to the original equation, I think we might be able to tell, just in our heads, another value of x that works. Give this a pause for a quick 15 seconds. Can you tell just kind of in your head, by guess and check, what other value of x works here? Pause it in 4, 3, 2, 1. Pause it just for a quick 15 seconds. All right, so hopefully you thought about that. It turns out that 0 also works. So why did I not get that as an answer? Well, it has to do with this step where we divided. Because in that step, the denominator, which is x, cannot be equal to 0, because that makes it undefined. And that's exactly the answer that we ended up losing. So the moral is that we can lose solutions, I'm going to abbreviate solutions, when dividing by a variable. When dividing by a variable. And I'm going to put that in a little thought bubble. You can lose solutions when dividing by a variable because we run into this problem where we might be dividing by 0. So then what's the correct way of solving this? I got x squared equals 4x. I bring all the terms to one side first. So I get x squared minus 4x equals 0. And then we could factor that. So x times x minus 4 equals 0. And now I get both of the answers. I get x equals 0 as well as 4. So for part B, is there a unique x such that s of x, this equation is true? Well, no, there isn't just one. So this statement is false since there isn't just one value of x that works. There are two values of x that works, and that doesn't make this unique x statement true. However, if we were to instead consider the statement, does there exist an x such that s of x is true? Then the answer would be yes, because for there exists, there just has to be at least one. So 2 is definitely good enough for that. For this, we just need at least one x, and there definitely is at least one x. This one would have been true. Okay, and that's the difference between there exists a unique x and there exists an x.